Hey mathletes, it's Mr. Nolde here. What's up? Quick example today showing you how to use the synthetic division that we learned in a couple of videos ago and how to use it to do something called the remainder theorem, or use what's called the remainder theorem. So just a quick example for you. I'll be right back. All right, so here's the remainder theorem. How the remainder theorem goes is we take a polynomial and we're going to divide it by. We know we can only use synthetic division with x minus c, but that doesn't matter when we're using the remainder theorem. If I have a function and I want to know what is f of 5, that means that x minus 5 was my x minus c, and whatever the remainder of this division is going to be my f of c. My f of 5, I should say. So let's look at an example here. I'm going to switch pages, and I'm going to show you x to the third power plus 5x squared minus 9x minus 45. Okay, so let's suppose I want to know, this is my polynomial function. I want to know what is say p of 5 or p of negative 5. Well, that would have been x plus. We'll try negative 5 anyway. So 1, 5, negative 9, and negative 45 are my coefficients. Now notice x cubed, x squared, x, and a constant. So I don't have to put any placeholders in here. So how this works is I drop the first digit. And then I'm going to multiply. Different people put this in different places. I tend to put it down here. But how we do this again is negative 5 times 1 equals negative 5. Then I can add 5 and negative 5, which gives me 0. Then we multiply negative 5 times 0, which gives us 0. Then I'm going to add negative 9 plus 0 to get negative 9. And then I'm going to multiply negative 5 times negative 9. And that gives me a positive 45. So when I add these two numbers, negative 45 and 45, I end up with a 0. So that tells me that p of negative 5 is actually 0. All right, let's pick another value maybe that you want to try this out for. Let's say, I'll get a new page here. X cubed minus 7x, how about plus 6? I'm picking one that I need a placeholder for. So, but I want to know, this is my function, polynomial function, and it's equal to x cubed minus 7x plus 6. I want to know what is p of 6. What is p of 6 equal to? Well, the easiest way to figure this out, or one of the easiest ways to figure this out, is to put down our coefficients in descending order. So notice I have a 0 here because there's 1x cubed. There's no x squared term. There's a 7x, negative 7x, and then my constant is plus 6. So I'm going to multiply through here, and I'm using a 6. So I drop the 1. What is 6 times 1? Again, that is 6. So I add 0 plus 6 to get 6. Then I multiply 6 times 6 to get 36. Then I add negative 7 and 36. That gives me a 29. And then 6 times 29. Well, that's 6 times 20, which is 120, plus 6 times 9, which is 54. So that is 174. So we add the 6 and the 174, and we get 180. So that tells me that p of 6 is 180. So again, this is, remember, called the remainder theorem. It's kind of a neat little thing that we can use now that we know how to do synthetic division. So looking back at this one for a second, this is going to lead us into our next lesson, which is the factor theorem. But the fact that we had a no remainder, a 0 remainder, that means that if negative 5 has no remainder, that means that x plus 5 was one of the factors. So that's like saying x plus 5 times, let's see, I have 1x squared. There's no x term, minus 9, so minus 9. So that means that p of x factors thusly, like this. I could actually factor this further now that I see it, x plus 3 and x minus 3. But I just wanted to come back and let people know there's no remainder here. That means that this negative 5, which came from x plus 5, is one of the factors. So that's an upcoming video. It's called the factor theorem. In any event, thanks for watching. Appreciate it. Make sure you like, subscribe, post a comment, share this with anybody who you think might benefit from it. I do appreciate it.
So there you go, one quick example on the remainder theorem. It's an extension of synthetic division, but it's very useful. Sometimes students will say at this point, why didn't I know how to do this back in Algebra 1 or Algebra 2? Well, the answer is you didn't know how to do synthetic division then. I guess that's a good enough answer. So, but anyway, you now know how to figure out the value of a function, as big of a function as it could be, using a simple process now. So anyway, thanks for watching to the end. I do appreciate it. Give it a like if you got value from it. Also, consider leaving a comment. Leave me a comment with any other problems you might like to see. Also, go ahead and share this video with anybody who may find it helpful. And of course, always consider a subscription. Would appreciate that so much. In any event, this is Mr. Nolde signing out. So take care until the next one.